things simpler in the long run, but a little bit more complicated in the short run, is try to take the derivative with respect to the quality, holding fixed the number of people who consume the product, rather than holding fixed the price. So to do that, and the reason that I'm going to do that is we're really trying to not figure out the overall level of quality, but sort of how they choose the trade-off between, choosing a higher quality versus a lower price, right? Sort of holding fixed the number of people who consume. Okay, so let's try to take, let's try to figure out how we can take the derivative of this with respect to rho holding fixed the number of people. And Ben, do you want to, I think it was supposed to, yeah, Ben, do you want to start, helping us think about how we can do this? How could we figure out how much the price has to increase when the quality increases in order to hold fixed the number of people?
I mean, I see what you're doing on the side. I just don't. I'm not sure I exactly understand why.
Okay. Well, so what we want is that when we increase the quality, the price adjusts so as to hold fixed the number of people. Right? So what does that mean? That means the total derivative of the number of people with respect to the quality should be equal to 0. And there's two components in that total derivative, right? One is the direct effect of quality on the number of people. The second is an indirect effect, which is that the price adjusts in order to hold quality fixed. And then there's the effect that change in price has on the number of people, right? So those two terms together have to be equal to 0. Now what's this first term? Well, we know that the effect of price on the number of people is negative m, right? What is the effect of a change in the quality on the number of people? Well, we can again use Leibniz's rule, right? So we want to take the derivative of this with respect to rho. So that's again rho, the number of people, was here. We want to take the derivative of this with respect to rho. How do we do that? Well, again, it's going to be something along the boundary. But notice that rather than the derivative of this boundary condition being 1 with respect to price, it's u sub rho, or it's u prime, right? So we're going to integrate along the boundary u prime times f, rather than just f, right? So that's Leibniz's rule. So we integrate along the boundary u prime times f. Okay. So now I want to, again, we don't want so many integrals floating around. I'm going to make a definition. What is the integral along the boundary of u prime times f? Well, that's just the number of people that are on the boundary, m, times the average value of their marginal utility. Right? The average value of u prime for them. So we can rewrite this thing as m times u prime, and I'm going to put this tilde over things which are averages taken along the boundary. Okay. So then this becomes negative m times dp d rho plus m times u prime tilde, which is again the average marginal utility of people who are on the boundary, average marginal utility of marginal consumers. And so just solving that out, we divide through by m, and we get that the price has to increase when the quality increases by the average marginal utility of marginal consumers, which is pretty intuitive, right? If I don't want anyone to leave or enter the market, when the quality goes up, the price is going to have to rise in correspondence with the average value people place on that, so that nobody enters or exits. Okay, so this gives us the derivatives of social welfare with respect to, this gives us the derivative of social welfare with respect to a change in the quality holding fixed the number of people. And Andy, could you take us through how to do that? So what we now know is how much the price changes when rho changes, right? We can also look at the direct effect of changing rho. So, yeah, so what is that going to give us when we take the derivative of this? Think about Leibniz's rule, right? We want to take the derivative of this integral. Let's first just think about the direct effect of rho on this integral, okay? Let's forget about the indirect effect of price. So what would the direct effect of rho be on this integral?
So rho has the effect on the boundary
Yes.
of the integral, right? So when rho goes up, that means the utility from consumption goes up.
Yeah?
And then it also has effect on the inside of the integral, which increases the utility as well.
Yeah, so what's the boundary expression going to look like? So it's going to be the integral along the boundary of something, but what's that something?
It's
Well, so you just have to take the derivative of the boundary expression, and then you multiply that by the inside of the integral, and you take the derivative around the boundary.
Okay, so when you take the derivative of the boundary, it will be like the marginal utility.
Exactly.
U prime.
Yes.
And when you multiply that with the inside, it will
Yeah.
be utility times like marginal utility. So
Yep, that's right.
what does that equal to?
Yes, so you get what Andy just said is you get the integral along the boundary of u tilde, u prime times u times f, right? And then what's the derivative in the interior?
It will be just sometimes that, like,
Well, it's u prime, right? Because you have to take the derivative. So you get the integral over the interior, right? So those are two terms. And then
minus the cost.
minus the marginal cost. Okay, good. Now, how about when you take the derivative with respect to price? We know price is going to increase by u tilde prime, u prime tilde. And what happens when we increase the price of this? How much does that?
Isn't that just equal to that big integral over n?
Yes, so it's this that it's when we increase the price, right?
Yep.
That's just going to be m, right? That's how much the number of people goes down times the utility of people who are on the margin, right? But everyone who's on the margin is a utility which is equal to price,
Yeah.
right? That's the definition of the margin. So we get minus u prime tilde times p times m. Okay, now what do we see? Look at this expression here. Again, the utility of people on the margin is exactly equal to the price. So we can take out this u here, and we can make that into a p. Now notice that this expression and this expression are exactly the same. Both are the integral of the utility along the marginal utility along the boundary, so we can completely cancel out this and this one term. And we end up with this expression. Now, why were we able to cancel out what was going along on the boundary there? Well, the reason is because we're holding fixed the number of people. So the whole reason that I wanted to figure out this whole BS about holding fixed the number of people is so we could ignore that term. Yeah, Andy. Anthony. Yeah.
So like, the reason we don't have to consider the effect of the price on the utility of the people in the interior is because we're considering social welfare. So,
We do have to consider the value of the people on the interior.
as in the effect of the price.
Oh, yes. So the price does not affect people in the interior because it's just a transfer between.
Yeah. So
Yes, exactly. Okay, so this gives us the derivative is the integral over the interior of the marginal utility times the number of people minus the marginal cost of quality. And if we define the average marginal utility for an average consumer rather than a marginal consumer to be this divided by the number of people, then we obtain this simple formula. So the optimum is to set the number of people times the average marginal utility they get from higher quality equal to the cost of providing quality. And that's just like super intuitive, right? It's just saying that if we can make these many people this much more happy at this cost, that's what we should do, right? Now, how about taking the derivative of profits with respect to quality, holding fixed the number of people? Alex, could you?
So you would want to take.
So we're holding n fixed, so you can completely ignore n,
Yes,
right? So all you need to do is take the derivative of p and of c with respect to rho.
I mean, the derivative of p with respect to rho is 0, isn't it?
Well, so we actually solved out for that here, right?
Oh, okay, right. Oh, okay. So then it'd be the number of people times the utility expression.
Yeah,
Well,
exactly.
equals the cost.
And then what's this?
It's
Derivative
CP.
c sub rho, yeah.
Or C rho, sorry.
Yeah, exactly. That's exactly right. Okay, so that gives us a different expression. Abigail's not here, is she? Well, you know, the expression is just setting this equal to 0 gives us that the profit maximizing level of quality is to set the number of people times the average marginal utility of a marginal consumer equal to the marginal cost of quality. So the socially optimum was to set the average marginal utility of the average consumer. This is to set the average marginal utility of a marginal consumer, someone who's indifferent between consuming and not. So this is called the Spence distortion. You cater to marginal rather than to average consumers. That means that quality will be too high or too low depending on whether the marginal consumers value it more or less than the average consumers do. And one force that can offset this is sometimes inframarginal consumers have something that they can do other than just not buying the product to try to influence the product. They can like put complaints on the website or something like that. So if you're stuck using a product but you're pissed off about it, you can just complain or protest and whatever. And in fact, there's a famous book called Exit, Voice, and Loyalty by Albert Hirschman that's all about this. Okay, so let me give you one very simple example of this in practice. So does everyone understand the basic effect? The monopolist relative to the social optimum always caters to the marginal consumers in terms of how the products are designed rather than to the average consumer. So one very simple example of this is given by Hotelling's model, in which the product characteristic is just your position along some line. And this is sort of a classic example of horizontal characteristics because, you know, there's just, you're at some position along the line, consumers live at different positions along the line, and they like you if they don't have to travel far to get to your store, right? And consumers are always going to buy one of two competing products.